Welcome viewers and subscribers to AID-ucate. I'm Mr. J. Today we'll be doing some vectors questions, multiple choice question. Stay tuned. Here we have a typical CSEC multiple choice question on vectors. So we're given a diagram and you are asked to represent it in the column vector notation. What we need to realize is that this vector here, OQ, notice that it starts at O. The tail of our vector is at O. Where is O? O is at the origin. And so our position vector here, yes, it is called a position vector. It has a x component of -3 and a y component of 8. And so our column vector is -3, 8. So our answer here is B. This question is similar to the one that was done before, but this time I hope that you are able to notice that we are given coordinates of the point P. So we're given 4 and 7 as the x and y coordinates respectively. So one important thing to note that we are dealing with a position vector. That means that the tail begins at the origin. So this distance here that is parallel to the x-axis, this is going to be 4. And this distance here that is parallel to the y-axis, that is going to be 7. So we can note that and draw the relationship. Remember that the x and y coordinates of a point and the position vector of the set point, that the x component and the y coordinate, they are the same, and the x or the y coordinates and the y components are the same. So we should have 4, 7 for our answer. So therefore our answer here is D. In this question, we're asked to find the magnitude of vector OB. So how do we do that? Remember your formula. So you should have OB, vector OB, and it is enclosed by 2 vertical bars indicating magnitude. We use our Pythagoras theorem. So we find the square root of the x component squared plus the y component squared. So we substitute the values in. So we have 4 squared plus -9 squared. Or we simplify. 4 squared, 16, plus we have -9 squared, 81. So our answer is the square root of 97. And the option here, A, is correct. In this question, we are given 2 vectors, vectors P and vectors Q. And we are to determine if these 2 vectors are perpendicular to each other, whether they are unit vectors, whether they are parallel to each other, or they are equal vectors. So it is always good practice to look at the x and y components of each of these vectors. They are not the same, but we notice that they have the same sign before them. There's a negative sign before each of these components. So The other thing that we could do is to look to see if we can do anything to any of these vectors to get the other. What do I mean by that? Can we multiply any of these vectors by a scalar quantity to get the other? So if you have noticed that, let's look at vector q. Now vector q is -3, -4. Can we multiply this vector by a quantity to get -18, -24, that is vector p? So if you have noticed this, it would be 6. So let us do that. So we have 6 times -3 and 6 times -4. And that would give us -18, -24. And so we realize that 6q is equal to p. So p is a scalar multiple of q, and therefore these two vectors are parallel vectors. For this question, we are given two vectors, vector r and s, and we are asked to determine whether they are unit vectors, inverse vectors, equal vectors, perpendicular vectors. So it is good practice to look at the x and y components of our two vectors. And you notice that the x and y components, they are the same. Now this is good because we can clearly say that their magnitudes are equal. Now I can almost hear you wondering and saying, are they equal vectors? Now the signs, based on what we're seeing here, the signs attached to the x and y components of our vectors, they are the same. But we need to ensure that we look closely. For our vector s, we have a negative outside the bracket. What does that mean? So let me expand. So we have s, vector s, and we have a scalar quantity, -1 outside the bracket. So if we should expand that and simplify, we have -1 times -6, and we have -1 times 7. So the x and the y components are multiplied by the scalar quantity. And so what we have now is 6 and -7. So from this, we can see that vector r and vector s are inverse vectors. So that would be B for this one. So we can pull up a grid and we can also plot these vectors on our grid. So let me show you the x component of vector r and the y component. And look at the direction of our vector r. And let me now show the x component and the y component of vector s. And let us look at the direction of vector s. Now we can look and observe to say, yes, their magnitudes are the same. Vectors r and s, their magnitudes are the same. But one could say that they are oppositely parallel. They are parallel to each other, but they are going opposite to each other. And from our calculation here, we can see also that vector r is a scalar multiple of vector s. This question is similar to the one that we just did. We're given two vectors, vectors m and n, and we are asked to determine whether they are equal vectors, perpendicular vectors, unit vectors, or inverse vectors. So it's good practice to look at the x and y components of both vectors. In this case, they are the same, and so we know their magnitudes are the same. But we take a closer look and realize that the x and y components in terms of the sign, they are not the same. So we could take any of our vectors. We could take vector m, multiply it by -1, and we should get n. Or we could say take n and multiply it by -1, and we would get m. So these two vectors are inverse vectors. In this question, we're given two vectors, vectors a and b, and we are asked to find the sum of 3 times a and 2 times b. So we could write that out. 3 times a plus 2 times b. And that would equal to, we have the scalar quantity 3 times -4. We have 5 there, plus 2 times, and we have 2, -3. Can simplify that. 3 times -4, 3 times 5. And for this one, we have 2 times 2, 2 times -3. So we realize that the scalar quantity is multiplying the x and y components of each column vector. So we continue. 3 times -4, that would be -12. 3 times 5, that would be 15. Plus, on the right side here, we have 2 times 2, that would be 4. 2 times -3, that would be -6. And we add -12 plus 4, and that would give us -8. And we have 15 plus -6, and that would give us 9. So our answer here is -8, 9. So that would be B. For this question, you are given the unit vector notation and you are asked to write it in the column vector notation. So the long and short of this is that, if you want a quick fix, is to realize that the coefficient of vector I is replace the x in the column vector notation, and the coefficient for vector j replaces the y component in our column vector. So our answer for this one would be 3, -7. So this one would be C. But if you want to further understand the idea, what I just spoke about can be represented like this, where you have the unit vector notation. And this shows how the unit vector notation and the column vector notation, how they relate in an equation, right? So let us look at it further. For this question, I know that for how it is represented here in the unit vector notation, I know that you're saying that what about if you're given a negative coefficient like what is shown here? But think about it as adding a negative integer like this. And I want us to also think about what a unit vector is. A unit vector has a magnitude of 1 unit. So we have 3 times a particular unit vector that is actually parallel to our x-axis. What does that mean? So let's pull up our grid again, and the coefficient here telling me or telling us that we have 3 groups of unit vectors and they're adding, right? So when vectors add, the head runs into the tail of another vector. So look to your right now and you will see this. So this is our first unit vector that runs parallel to our x-axis and it goes to the right because our coefficient is positive. So that's 1, 2, 3. So that would be 3i. And then we add to that 7 j's, but these j's are negative, right? These unit vectors, they are running parallel to the y-axis, and because they're negative, they go down. 1, 2, 3, 4, 5, 6, 7. Now the thing is, from start to finish, we could have a resultant vector showing that distance, like so. All right, and what would be the x and y component of this resultant vector? Well, you guessed it. It is 3, negative 7. So I hope that this content was good, and if you like our content, please subscribe to our channel, AID-ucate, and hit up that notification bell so that you can be apprised of new content. All right, stay safe and take care.